Welcome, YouTubers, to another episode in my Grammar Hero series. In today's video, we're going to take a look at solving one step, two step, and advanced inequalities. More specifically, I'm going to work out 10 practice test questions that should closely mirror what you should expect to see on both the Armed Services Vocational Aptitude Battery, that is the ASVAB, as well as the pre-screening Internet Delivered Computer Adaptive Test, that is the PiCAT. As always, in order to get the most out of this video, you'll want to pause the video after I read a practice test question, attempt to work out that question on your own, and then resume playing the video to check your solution. As a reminder, on the actual ASVAB and PiCAT, you will not be permitted to use a reference sheet or a calculator, so try not to use any of those resources as you work through these practice test questions. Finally, I want to say this video is a very accurate reflection of how difficult the ASVAB and PiCAT are. In other words, if you can answer 7 or more of these questions correctly on your own, then you are ready for the ASVAB and PiCAT, at least in terms of your ability to solve inequalities. For that reason, I don't recommend that you spend a lot of time learning about inequalities. One video should be more than enough practice for you to master this very basic concept. So with all that being said, let's go ahead and get started with this video. All right, so the very first thing I want to point out is this. Solving inequalities is almost the same thing as solving equations. That said, there are two key differences between solving equations and solving inequalities. The first one's right here. It says, if you multiply or divide by a negative number across the inequality sign, you must switch the direction of the sign. So let's take a look at a few examples so I can illustrate that difference. So this first example says x plus 5 is greater than 1. Let's go ahead and solve this one. We have x plus 5 being greater than 1. In this case, we want to get x by itself, so the only thing we have to do is subtract 5 from both sides. This crosses out, leaving you with x greater than 1 minus 5 is negative 4. Now you noticed that I did not switch or change the direction of my inequality sign. Why? Well, I just subtracted here. I did not multiply or divide by a negative number. You can add and subtract across the inequality sign all day long. That does not affect the direction of the sign. Now let's take a closer look at example 2. Notably, negative 2x is greater than 6. All right, so we want to get x by itself. To do that, we're going to divide both sides by negative 2. This crosses out here, leaving me with x on this side. But because I divided across the inequality sign by a negative 2, that's going to prompt me to change the direction of its sign. So instead of being greater than, it's going to flip to be less than. And of course, 6 divided by negative 2 is negative 3. All right, so again, one of the key differences between solving equations and inequalities is the fact that if you multiply or divide across the inequality sign by a negative number, you have to change the direction of the sign. And we saw that right here in this second example. All right, so the second most notable difference between equations and inequalities is the fact that you graph your solutions to inequalities on number lines. And let me just say this, as far as inequality signs go, there are 4 of them. There's greater than, less than, greater than or equal to, less than or equal to. When you graph greater than or less than on a number line, you use an open circle, meaning that you don't include that value. And when you graph greater than and equal to or less than and equal to, you use a closed circle. All right, so let's take a look at 2 examples where we're asked to graph solutions to an inequality. In this case, we're being asked to graph x is greater than 2. So the first thing we want to do is go to 2 on our number line, which is right here. We know we're working with an open circle since we have a greater than symbol. So we're going to put an open circle above 2. And again, this says x is all the values that are greater than 2. Well, what are all the values greater than 2? That's 3, 4, 5, 6, 7, 8, 9, and 10. So we'll go ahead and draw an arrow like that to indicate that those are all the values meeting this criteria. All right, let's look at the second example now where we're asked to graph x is less than or equal to -2. So since we have a less than or equal to sign, we know we're going to be working with a closed circle. And of course, we're going to go to -2 and place our closed circle there. In this case, let's read this. X is all the values that are less than or equal to -2. Well, which values on this number line are less than or equal to -2? Well, that's -3, -4, -5, -6, and so on and so forth. So we're going to draw our arrow this way to indicate that all those values are solutions. All right, and that's all there is to graphing. Open circle, closed circle. Read the solution, draw your arrow accordingly. All right, so now that we have those two things in mind, let's go ahead and work on those 10 practice problems. Again, at this point in the video, you may want to pause the video, attempt to work out these questions on your own, and then resume playing the video to check your solution. First, we're going to solve the inequality, and then we're going to graph that solution on a number line. All right, so this first question says if x plus 6 is less than 7, then x is. All right, so we have this inequality x plus 6 is less than 7. Again, the key to solving an inequality is to get the letter variable by itself. In this case, it takes one step to do that. Notably, we just have to subtract 6 from both sides of the inequality. This crosses out, leaving you with x on this side. X is less than 7 minus 6 is 1. Again, since I subtracted across the inequality sign, I did not have to change its direction. So the correct answer to this one is A, x is less than 1. And of course, let's go ahead and plot this solution on a number line. Since we have a less than symbol, we know we're going to be using an open circle. More specifically, we're going to go to 1, which is right here. We're going to put our open circle down. And this says x is all the values that are less than 1. Well, which values are less than 1? That's 0, -1, -2, -3, and so on. So we're going to draw our arrow that way. Again, that's all there is to it. If you can solve equations, you can solve inequalities. All right, so number 2 says if x minus 9 is less than or equal to -5, then x is. So we're trying to solve the inequality x minus 9 being less than or equal to -5. As we would when we solve equations, we're trying to get our letter variable by itself. So in this case, we're trying to get x by itself. To do that, we're simply going to add 9 to both sides of the inequality. In doing so, that crosses out, leaving us with just x on this side of the inequality. And we're not going to change the direction of our sign since we just add it across the inequality sign. -5 plus 9 is 4. All right, so the solution to this one is x is less than or equal to 4. And we can see that that is answer choice A again. Let's go ahead and graph this solution on a number line. Since we're working with a less than an equal to sign, we know we're going to be using a closed circle. Let's go to 4 on our number line and drop that closed circle right there. And this says x is less than or equal to all the values less than 4. So all those values are 3, 2, 1, 0, -1, and so on and so forth. So we're going to draw an arrow going this way. All right, that is that one. That's all there is to it. So number 3 says if -3x is greater than or equal to -15, then x is. So we're trying to solve this inequality now. -3x is greater than or equal to -15. Of course, as we would when we solve an equation, we're trying to get our x variable by itself. So we're going to go ahead and divide both sides of this inequality by -3. This crosses out here, leaving you with x on this side. And what did I just do? I just divided across the inequality sign by -3. So that's going to prompt me to change the direction of this sign. So I'm going to do that real quick. X is now less than or equal to negative 15 divided by negative 3. A negative divided by a negative is a positive. 15 divided by negative 15 divided by negative 3 is going to be positive 5. All right, so the solution to this one is x is less than or equal to 5. We can see that that is answer choice B. Let's go ahead and graph this solution now. Again, we know we're using a closed circle since this is less than or equal to. We're going to go to 5 on our number line. We're going to drop down our circle. Then we got to determine which way our arrow goes. Again, this says x is all the values that are less than or equal to 5. Which of these values are less than 5? Well, that's 3, 4, 2, 1, and 0. So we're going to draw our arrow going that way. That's all there is to it. If you can solve equations, you can solve inequalities. So number 4 says if x over 2 is greater than or equal to negative 3, then x is. So for this one, it might be helpful if you write out this imaginary 1 in front of this x, which will enable you to rewrite this inequality like this. 1/2 of x is greater than or equal to negative 3. All right, so now our task is to get rid of this 1/2 in front of our letter variable x. And to do that, we're going to multiply it by its reciprocal, which is 2 over 1. We're going to have to do that to both sides of our inequality to keep it balanced. Again, this crosses out here and here, leaving you at just x on this side. And let's think about what's going on here. We have negative 3 times 2 over 1. Well, what is 2 over 1? 2 divided by 1 is just 2. So in reality, we have negative 3 times 2. Negative 3 times 2 is simply negative 6. So the solution to this one is x is greater than or equal to negative 6. And we can see that that is answer choice A. Let's go ahead and graph that solution on a number line. Again, since we have a greater than or equal to symbol, we know we're using a closed circle. So let's go to negative 6 right here, put our closed circle there. And this says x is all the values that are greater than or equal to negative 6. Well, which of these values are greater than negative 6? Well, that's negative 5, negative 3, 0, 1, 2, 3, 4. So our arrow is going to go this way now. Again, that's all there is to it. These are so simple, you really don't need 5 videos on solving inequalities. All right, so number 5 says this: if x over 3 is greater than 5, then x is. All right, so we're trying to solve the inequality x over 3 is greater than 5. Of course, if it's helpful, you can put that imaginary 1 in front of the letter variable x, which enables you to rewrite the inequality like this. 1 over 3x is greater than 5. Now, clearly, we're just trying to get x by itself. And to do that, we're going to multiply both sides of the reciprocal of 1/3, notably by 3 over 1. In doing so, we get to cross these out, leaving us with just x on this side of the inequality. Of course, that's going to be greater than. And what do we have going on here? We have 5 times 3 over 1. What is 3 over 1? 3 divided by 1 is just 3, so this is 5 times 3. 5 times 3 is 15, so this says x is greater than 15. Of course, that is answer choice B. And let's go ahead and graph that on our number line. I'm going to have to make my number line a little bit bigger. So this is going to be 11, 12, 13, 14, 15, 16, 17. This says x is all the values that are greater than 15. Since we have a greater than symbol, we know we're using an open circle above 15. And what values are greater than 15? Well, that's 16, 17, and so on. So our arrow is going to go that way. All right, so number 6 says, if 6x minus 8 is greater than 22, then x is. So we have 6x minus 8 greater than 22. So our goal here, of course, is to get the letter variable x by itself. First step we're going to do is to add 8 to both sides of our inequality. In doing so, we get to cross those out. That leaves us with 6x is greater than 22 plus 8 is going to be 30. Now, to get x by itself, we're going to divide both sides by 6. This crosses out, leaving you with x on this side. 30 divided by 6 is simply 5. So our solution is x is greater than 5. And let's go ahead and graph our solution now. Again, we're working with an open circle since we have a greater than symbol, and we're going to go to the value 5. This, this solution says x is all the values that are greater than 5. What values are greater than 5? Well, 6, 7, 8, 9, and 10. So our arrow is going to go that way. Negative 4 minus 5v is less than negative 29, then v is. So we're trying to solve this inequality. Negative 4 minus 5v is less than negative 29. All right, so again, our goal is to get our letter variable by itself ultimately. And to do that, we're going to start by adding 4 to both sides of our inequality. In doing so, we get to cross this out. This leaves us with negative 5v is less than what is negative 29 plus 4? Well, that's going to be negative 25. All right, so now we want to get v by itself, and we have one more thing to do that. We're going to divide both sides of this inequality by negative 5. This crosses out here, leaving you with just v on this side. Now, what did I just do? I divided across my inequality sign by a negative 5. So that's going to prompt me to change the direction of my inequality sign. So instead of being less than, I'm going to flip it to be greater than. And what is negative 25 divided by negative 5? A negative divided by negative is a positive. Negative 25 divided by negative 5 is simply 5. So the solution to this inequality is v is all the values that are greater than 5. We can see that that is, in fact, answer choice A. Let's go ahead and plot this on our number line. We're going to go to the value 5. And since we have a greater than symbol, we're going to use an open circle. And this says v is all the values that are greater than 5. What values are greater than 5? Well, 6 is greater than 5, 7 is greater than 5, 8 is greater than 5, 9 is greater than 5, 10 is greater than 5. So our arrow goes that way. Negative 2 plus r over 9 is greater than negative 1, then r is. So we're trying to solve the inequality. Negative 2 plus r over 9 is greater than negative 1. In other words, we want to get r by itself in this inequality. The first thing we're going to do, of course, is add 2 to both sides of our inequality. This crosses out, leaving us with r over 9 on this side. Of course, that's greater than negative 1 plus 2 is simply 1. And now we want to get r by itself. And if it's helpful, you can rewrite this. Again, there's an imaginary 1 in front of this r. So you can rewrite this as 1/9 r is greater than 1. To get rid of this 1/9, we're going to multiply both sides of our inequality by its reciprocal, notably 9 over 1. This crosses out here and here, leaving you with r on this side. Of course, this says r is greater than, what is 1 times 9 over 1? Well, let's do that off to the side if we need to. What is 9 over 1? 9 divided by 1 is just 9. So this is 1 times 9. 1 times 9 is 9. So this says r is greater than 9. We can see that is answer choice B. And again, as you graph this, let's keep these things in mind. We know we're going to the numerical value 9 on the number line. And since we have a greater than symbol, we're going to use an open circle. This says r is all the values that are greater than 9. Well, what's greater than 9? 10's greater than 9, so we know our arrow goes that way. All right, so number 9 says if 8 minus 7n is greater than or equal to negative 20, then n is. So we're trying to solve the inequality 8 minus 7n greater than or equal to negative 20. All right, so we're trying to get the letter variable n by itself in this inequality. The first thing we want to do is subtract 8 from both sides of it. In doing so, we get to cross this out, leaving us with negative 7n on this side. It's greater than or equal to. Again, I just subtracted across the inequality sign, so I do not have to change its direction. Negative 20 minus 8 is negative 28. Okay, now to get n by itself, we're going to divide both sides by negative 7. In doing so, we get to cross this out. This says n. And what did I just do there? I divided across the inequality sign by a -7. So now I have to change the direction of the inequality sign. So as you can see, I went from being greater than or equal to less than or equal to. That is to say, I flipped its sign. And now we have -28 divided by -7. A negative divided by a negative is going to be a positive. -28 divided by -7 is going to be +4. So the solution to this inequality is n is less than or equal to 4, which we can see is B. Let's go ahead and graph this on our number line. Again, we have a less than or equal to symbol. So we know we're going to go to 4 and put a closed circle above it. This says n is all the values that are less than or equal to 4. What values are less than 4? Well, 3 is less than 4, 2 is less than 4, 1 is less than 4, 0 is certainly less than 4. So our arrow is going to go this way. All right, so number 10 says if -32 is less than 8 minus 5k, then k is. So we're trying to solve this inequality. -32 is less than 8 minus 5k. So we want to get the letter variable k by itself. The first thing we're going to do is subtract 8 from both sides. This crosses out, leaving you with -5k over here. -32 minus 8 is going to be -40. Again, you can add and subtract across the inequality sign all day long. You do not change its direction when you add and subtract. All right, now we have to get k by itself. And in order to do that, we're going to divide both sides by -5. This crosses out here, leaving you with k on this side. And what did I just do? I divided across the inequality sign by a -5. So that's going to prompt me to change the direction of the sign. Now we have -40 divided by -5. A negative divided by negative is a positive. -40 divided by -5 is +8. All right. So if it's helpful, you can rewrite this one. Again, in math, it's customary to write the variable for which you solved on the left. And the way I like to do this one is like this. Look, I know that this point is pointing at the k. So when I rewrite it, my point has to point at the k. And this says k is less than 8. So the solution to this one is k is less than 8, which is C. Let's go ahead and graph it on our number line. Again, we're going to the value 8. And since we have a less than symbol, we know we're going to be using an open circle because we're not going to include 8. And then this says k is all the values that are less than 8. What values are less than 8? Well, 7, 6, 5, 4, 3, 2, and 1, and so on and so forth. So our arrow is going to go that way. All right, so that is it for this video. As I said at the start of this video, if you can solve equations, you can solve inequalities. You just have to keep those two differences in mind, notably that if you multiply or divide across the inequality sign by a negative number, you have to change the direction of the sign. And instead of graphing something on a Cartesian plane, you're now graphing your solution on a number line with either an open or a closed circle. Apart from that, solving inequalities is almost identical to solving equations. If you can do one, you can do the other. And for that reason, you should always get these questions right on either the ASVAB or PiCAT. If you want to help my channel out, you can do one of two things. You can subscribe to it, or you can share links to my videos, including this video, on social media, including on Twitter and Facebook. As always, you're more than welcome to leave feedback in the comment section below. But on that note, I'm going to go ahead and cut you loose.